All right, topic number 6, trigonometry. Before you do anything for the SOL, make sure your calculator is in degree mode, because once you start going, you're going to forget to check. So as soon as you get your calculator and they say begin your test, make sure it's in degree mode. It's also helpful either on your scratch paper or on your formula sheet, if they give you a paper one, to write down Sohcahtoa. Just remember that sine of whatever angle is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. If you have trouble remembering these, this is the picture that's on the back of your formula sheet, or on page 2 of your formula sheet if it's the digital version. So from this angle, go straight across. Y is your opposite. Go across from your right angle. That's your hypotenuse, and the other side that's left over is your adjacent. Same idea, they just use different letters. But it tells you which sides to use for sine, cosine, and tangent. So let's look at some examples. The first thing you want to do is look at your angle that you're given and label your sides. Straight across from that is opposite. Straight across from the right angle is hypotenuse. The other side is adjacent. Then you're looking for what you're given and what you're trying to find. So I was given the adjacent side and I want the hypotenuse. So that's A and H. Cosine is the one that uses A and H. So now I know that cosine of 32 degrees is equal to 14 over x. When the x is in the bottom, just switch where the x is and the cosine is. And when you type that in your calculator, you get that x is 16.5, which is good. It's the hypotenuse, so it's the longest side, so it should be a number bigger than 14. All right, let's look at it. It's got an angle in a different position. Still start at the angle, go across from that, that's your opposite. Go across from the right angle, that's your hypotenuse. The side left over is your adjacent. So I'm given my adjacent again, and this time I'm looking for the opposite. So cosine of 69 degrees equals x. Sorry, we are not using cosine. What am I thinking? Opposite and adjacent is tangent. So tangent of 69 is x over 18. Since the x is on the top, we're going to take the 18 and move it to the other side. So x equals 18 times tangent 69. Type that in your calculator, and we get that x is 46.9. What if we're missing the angle? We're still going to label like we did before. So here's my angle. Straight across from that is my opposite. Straight across from the right angle is my hypotenuse. And the other side is the adjacent. So I am given opposite and hypotenuse. Since it's opposite and hypotenuse, I'm going to use sine. Because I don't know the angle, I'm going to put an x there. And sine is opposite over hypotenuse, so 12 over 30. Since we don't know the angle, we're going to have to use the opposite of sine, which is called sine inverse. It's got the little -1 exponent of 12 over 30. You'll find this by pushing second and then the sign button on your calculator. And when I type that into my calculator, I get that x is 23.7. 36 degrees. Now what about word problems? Everybody's favorite. The two key things in your word problems are going to be whether it's angle of elevation or angle of depression. If it's an angle of elevation, you're from the ground looking up. And if it's from angle of depression, it's if you were looking straight out and then tilted your eyes down. So it's this angle here. So an Air Force pilot must descend 1,500 feet over a distance of 9,000 feet to land smoothly on an aircraft carrier. What is the plane's angle of descent? So descent and depression, same idea. So if the plane kept flying straight out, it would be like this, but how far does it have to go down? So that's our x. We want to know what this angle is. We know we want the plane to land somewhere over here. So I'm going to make this my right triangle. It must descend 1,500 feet. So that's descend means down. So it's got to go down 1,500 feet over. So it's got to go over 9,000 feet. So it's got to go over 9,000 feet. So now that I have all my information labeled, I'm going to label my sides. Opposite, hypotenuse, adjacent. So I'm given an opposite side and an adjacent side, which means I'm going to use tangent. So tangent of x equals 1,500 over 9,000. And just like in our last example, we're trying to find an angle, we're going to use tangent inverse. So x equals tangent inverse of 1,500 over 9,000. And when I type that in my calculator, I get that x would be 9.5 degrees. And our last example, a man standing at point D, so the man's over here, watches a rocket take off from 1,000 meters away, which is right here. After 2 seconds, the man looks up at an angle of elevation of 34 degrees, so that's this angle here, and sees the rocket at a height of point B. After an additional 1 second, the rocket is at an angle of elevation of 36 degrees and a height of point A. What is the distance between A and B? So ultimately, we want to know this. But before we can know that, we need to know how far it is from C to B and C to A. So I'm going to sort of draw this as two separate triangles because I think that makes it a little bit easier. C, B, D. So when it's at point B, it has an angle of 34 degrees. And it's still 1,000 meters away. And we want to know how much this is. The second time he looks up, so from C to A with D, it's an angle of 39 degrees. He's still 1,000 feet away, and we want to know this height. So let's set up this triangle. Opposite, hypotenuse, adjacent. So we are going to we need to know our opposite, and we know our adjacent, so we're going to use tangent. 34 equals x over 1,000. So x equals 1,000 times tangent of 34. So x equals 809.8 meters. Now that we got that, we're going to look at our other triangle. We've got our opposite. We don't know our hypotenuse, but we know our adjacent. So we're going to use tangent again. So tangent of 39 equals y over 1,000. So y equals 1,000 times tangent of 39. When you put that in your calculator, we get that y, oops, sorry, I switched my numbers. Y is the one that's 809.8, and x should be 674.5 meters. So now if we subtract them, 809.8 minus 674.5, we get that the rocket has gone up 135.3 meters. Go ahead and work on your practice problem.